I'm Mike.
And I'm Kevin, and we're here to talk about continuity.
There are three things that must be satisfied in order to make a function continuous. First, the limit as x approaches c of f of x must exist. Second, f of c must exist. And third, f of c must equal the limit as x approaches c of f of x.
There are three types of discontinuity. The first is a hole, the second is a jump, the third is an asymptote.
This is a graph without a hole. This is a graph with a hole. Our first example of a problem with a hole in it is x squared minus 1 over x plus 1. When we simplified it out, we got x plus 1 times x minus 1 over x plus 1. The problem with this is that when x equals negative 1, the function becomes undefined. We then simplified the equation in order to make it more easily graphable. When the equation is simplified, the equation equals x minus 1, which there is a hole at x equals negative 1. As you can see from the graph, there is a hole at x equals negative 1 and y equals negative 2.
A jump occurs when the left and right hand sides of a point do not match. This commonly occurs in piecewise functions. Our example for a jump is this piecewise function. When x is greater than or equal to 2, the function is x squared plus 4. When x is less than 2, the function is 5x plus 2. To start this problem, you must look at one side of the equation. Looking at the right side of the equation, we can see when x equals 2, the function equals 8. Now we must look at the left side of the equation. When x equals 2 on the left side of the equation, we see that the function is equal to 12. 8 and 12 are not equal to each other. Therefore, we know there is a jump. Another easy way to tell a jump is to look at a graph's function. If there is a jump, you will see a distinguishable gap in the function, just like the one in front of you.
An asymptote is when the limit of a function at a point on either the left or the right side approaches positive or negative infinity. Our example is x plus 5 over x minus 3. When x equals 3, the function is undefined and therefore does not exist. This is what the graph of this function looks like. As you can see, at no point on this graph does x equal 3. The limit on the right hand side approaches positive infinity and the left hand side approaches negative infinity.
Now it's time for some example problems. For our first example, we must find if this function is continuous. The original equation is x squared minus 9 divided by x plus 3. This can be simplified to x plus 3 times x minus 3 divided by x plus 3. The equation becomes undefined when x equals negative 3 because there would be division by 0. By simplifying the equation and removing the x plus 3's, we can now get rid of the division by 0. But we must still remember there is a hole at the point x equals negative 3. Example number 2. Is this function continuous? If not, what kind of discontinuity exists? This function is a piecewise. When x is greater than or equal to 1, the function is x cubed plus 1. When x is less than 1, the function is 5x minus 3. The only place discontinuity can occur on this function is at x equals 1. We can look at both the left and right hand sides of this function at this point to find if discontinuity does exist. When we plug 1 into both these equations, we find that they both come out to be 2. So yes, the function is continuous. Example number 3 has the same directions as number 2. Find if the function is continuous. If not, where does the discontinuity occur? The original function is 5x cubed minus 10x squared plus 6x minus 12 divided by x squared minus 2x minus 15. The top can be factored by grouping, and the bottom can be factored using the quadratic formula. The function then comes out to be 5x squared plus 6 times x minus 2 divided by the product of x plus 3 times x minus 5. Looking at the function, we now see that there is no more simplifying that can be done, and we conclude that division by 0 would occur at x equals negative 3 and x equals negative 5. At these 2 points, there would be vertical asymptotes. Example number 4 also has the same directions as the previous 2 questions. Check if the function is continuous, and if not, what kind of discontinuity exists. This function is a piecewise function. When x is greater than or equal to 2, the function is x plus 5. If x is less than 2, the function is 3x minus 2. Since the only discontinuity that can occur is at x equals 2, we must check both sides of 2 to see if they match. By plugging in 2 to both sides, we find the left side is equal to 7 and the right is equal to 4. We can now conclude that a jump exists.